Okay, so one other theorem that we're going to look at, and again, we have the chromatic number is the least coloring. So what about, for the maximum degree of a graph or something like that? Can we find not necessarily the least coloring, but not exactly like just taking, well, I have n vertices, so it's n colorable. So we can look at another aspect of the graph. So we can say, okay, the theorem is going to be let G be a connected graph with the order of G equal to n, and then we can find if the maximum degree of the graph is equal to k, then our graph is k plus 1 colorable. Okay, so that's narrowing down the boundary of what the colors could possibly be, kind of a situation. So remember, the idea is you actually want the least coloring, but sometimes it is a bit hard to find the exact chromatic number, so at least having some form of boundaries so you can have like, well, you know that some graph exists in it, so your chi is going to be greater than or equal to the subgraph's chromatic number. And then you also want to, push down the upper boundary as well. So you go like, okay, I can find the maximum degree, and if I find the maximum degree, that chromatic number will be less than or equal to the k plus 1. So this is just helping us bind our chromatic number, because chromatic number will not necessarily be the easiest thing to find. So again, if we have the maximum degree of our graph, of our vertices of a graph, then we know that it is k plus 1 colorable. So this does narrow it down a bit, because like if you have a 27 order graph kind of a situation, and you have the maximum degree of your graph is 3, then you know it's 4 colorable. That's way better than saying, well, it's 27 colorable. So, again, it's narrowing it down.